So this is an interesting problem on the concept of drifting. So okay, so a boat moves relative to the water with a velocity which is n equal to 2 times less than the river flow velocity. So over here the boat's velocity is less than that of the water. So at what angle to the stream direction must the boat move to minimize drifting? Okay, first of all we'll draw a scenario. These are the two banks of the river. Now let's say, so our objective is to cross the river. So let's say the boat starts from point A. Its objective must be to, like, let's say the just opposite point is point B. So over here the river velocity is more than that of the boat, which means that it will not be possible for the boat to go from directly from A to B, because even if the even if the like hypothetically, even if the boat were to try to go in the opposite direction, the river velocity will be obviously more, so it will obviously be drifted in the rightward direction. And if it tries to move in any other direction, let's say at some angle, let's say this is just for explanation sake, so this is at some theta, then a smaller component of it will act in the reverse direction to the river flow, and so it will obviously be drifted towards the right, so it cannot reach B exactly. So what what does minimum drift mean here? So minimum drift means that it will drift onto the right side. However, let's say it is able to reach, sorry, so let's say it is able to reach to some point C, which is the right hand side of the line joining A and B. So we need to find out such a theta to the river flow. So let's say the river is flowing in this direction. Okay, so this is the river flow. We need to find such an angle. Okay, let's call it phi, not theta, at which the boat needs to be headed such that this distance BC is minimized. This is basically the drift. Drift is BC, so we need to minimize that. So how do we do that? So you already know that, so we assume that this is VR, the river flow velocity. Now let's say so obviously if the boat has to move in this direction, like somewhere, like it has to have a component which is opposite to the river flow so that the drift is minimized. If it goes in this direction, that wouldn't help, because that would obviously maximize drift, because there will be a component in the direction of river flow. So this can't be done. It has to move opposite to the river flow. It has to have a component opposite to the river flow, as well as, so this will be this, sorry, so it has to have a component opposite to the river flow. Okay, as well as it has to, so which is this, it also has to have a component that is towards, like, from A to B, so that it can reach to the other side of the bank, which is this. All right, now let's say this is, so I'm just drawing it here. This is, let's say, VB. Let's say it makes an angle theta with the river flow direction, or I will call it phi. Yeah, I'll call it phi. Okay, so all right, so phi is obviously an obtuse angle over here. All right, so let's consider this, and these are the components. So this is basically phi. So this is 90 degrees obviously. This is smaller angle is phi minus pi by 2. Okay, so basically VB, okay, or rather we can call this as, let's say, phi dash for now. So basically phi, the whole angle will be pi by 2 plus phi dash in terms of radians. Okay, now so this component will be VB cos phi dash, which will be in the direction of AB, and another component will be VB sin phi dash. Alright, so okay, so time taken. So now what we'll do is we need to calculate this distance BC. So distance will be basically the resultant velocity of the boat in the direction of the river flow, the resultant velocity, multiplied by the time taken to cross the river, sorry. So time taken T is basically, so let's say this AB, we call it as D. Time taken is the distance from one bank to the other divided by the velocity perpendicular to the river flow, which is VB cos phi dash. And this is the time taken, and the resultant velocity in the direction of the river flow, which we will just call V for now, is the velocity of the river. And since this is in the opposite direction, the boat's contribution towards that is minus VB sin phi dash, right? So now the drift, basically V into T, which is nothing but VR minus VB sin phi dash multiplied by D by VB cos phi dash. Now from the question we know that the water velocity is n times the river flow velocity is n times the boat velocity. So we'll just, so basically VR n times VB, VR equal to n times VB. So we'll just substitute that here. VR is n times VB, V sin phi dash multiplied by D VB cos phi dash. Will be cancelled out. Okay, so this is basically, this becomes n secant phi dash minus, and just dividing cos phi dash tan phi dash into D. Now the drift needs to be minimized. So what we can do is, here we'll apply differentiation. D drift by D, because the variable over here is phi dash, right? All others are constants. So with respect to phi dash, we need to maximize the drift. We need to minimize the drift. So this becomes, and this should be equal to 0. Alright, so secant phi dash with respect to phi dash would be secant phi dash tan to tan phi dash, and differentiation, n times this. See, tan phi dash differentiation will be secant square phi dash. Obviously D is a constant, so D, this is equal to 0. So obviously these just cancels out, yeah. So and uh, since okay, so this we'll just take out secant phi dash, right? Secant phi dash into n tan phi dash minus secant phi dash equal to 0. All right. So see, secant phi dash equal to 0. That can't happen because the value of secant theta is secant phi dash is basically 1 by cos phi dash, which means that the value can never be between -1 and 1. So this just means n, this is sin phi dash cos phi dash is equal to 1 by cos phi dash. Now obviously, like, yeah, you can cancel out cos phi dash, right? Because yeah, so because yeah, right. So this means sin phi dash is equal to 1 by n. So we were able to cancel out 1 by cos phi dash because again 1 by cos phi dash secant phi dash and that can't be 0. So that is why we were able to cancel out that. Phi dash is basically sin inverse 1 by n. So the angle which we needed was phi, which is pi by 2 plus phi dash. Phi is pi by 2 plus phi dash, pi by 2 plus sin inverse 1 by n. This can also be written as arc sine 1 by n. So basically that is the value, and of course you can substitute the value of n here and you can get the value in either radians or degrees as you require. So yeah, that's that. Thank you.